Hey there. In this video, we're going to discuss how do you find the domain of a rational function, how do you determine the vertical asymptotes of a rational function, and how do you find where there are holes in a rational function. So the first thing we want to discuss is domain, because the other two are related to the domain of a rational function. Remember that when we're looking at the domain of functions, we're looking for things that are going to cause us issues. And a rational function, by definition, is a polynomial function divided by another polynomial function. We have a fraction. If we've got one thing divided by another thing like that, we have a fraction. So the thing we need to really concentrate on is where would this function have a 0 in the denominator? This is going to be excluded from the set of all real numbers. So in the notes it would say any values that generate a 0 in the denominator must be excluded from the set of all real numbers. Okay, so remember, we're always starting with all real numbers, and then we're finding the values in that set that would cause issues. All right, so let's look at this first rational function. We have 3x squared divided by the product of x minus 5 times x plus 4. So obviously we see that we have a denominator function. There are values that are going to give us zeros when we sub them in for x. So we just take that denominator and set it not equal to 0. What's going to create us issues? So we can say x minus 5 cannot equal 0 and x plus 4 cannot equal 0. So our domain, x cannot equal 5 and x cannot equal negative 4. So we can say that our domain is all real numbers such that x cannot equal negative 4, x cannot equal 5. Can't equal 5. Another way to say that would be with an interval notation, which would be negative infinity to negative 4, union, negative 4 to 5, union, 5 to infinity. Either one of these is correct. And you could just say x can't equal negative 4 and x can't equal 5. That would be fine. Let's look at this one over here. F of x is equal to x plus 8 divided by x squared minus 64. Here we have a polynomial function on the bottom that's factorable, and so we would want to just go ahead and factor it. This is the same as x plus 8 divided by the product of x plus 8 and x minus 8. So we set this denominator not equal to 0, and we say, okay, x plus 8 can't equal 0, and x minus 8 cannot equal 0. Well, what does that mean that x cannot equal? X cannot equal negative 8, nor can it equal positive 8. Okay, so again, we can write it in set builder notation. So x such that x is not equal to negative 8, or x is not equal to positive 8, like this. Or we can say in interval form, negative infinity to negative 8, union negative 8 to 8, union 8 to infinity. Our last example for domain has to do with this function. F of x is equal to x plus 7 divided by x squared plus 49. Here we have a polynomial in the denominator, but it's not factorable. So let's just see what happens when we set it not equal to 0. Okay, so x squared plus 49 can't equal 0. That means x squared cannot equal negative 49. Oh, okay, so now we got like the square root of both sides, remember that? X cannot equal plus or minus the square root of negative 49, which means it can't equal plus or minus 7i. Okay, so x can't equal plus or minus 7i, but remember, where did we begin? We began at the set of all real numbers. This is not part of that set. These are the things that must be excluded to get a 0, but they're not even part of that set of all real numbers. So what's our domain? All real numbers, or from negative infinity to positive infinity. Another way to think about it, think to yourself, what can I square and then add to 49 and get 0 out? Well, if I square anything, it's positive. And if I add a positive to something positive, I'm not going to get 0. I'm going to get something positive. So there's absolutely nothing that actually works out there to make it a problem. Everything that I put in there is going to give me something positive out. So the next thing we're going to discuss is how do you recognize where vertical asymptotes are and where holes are by looking at the equation of a rational function. And really it boils down to what created issues in that denominator. What did we exclude from that set of all real numbers? Those will either be vertical asymptotes or holes. And how do you tell the difference? Well, if you find the zeros of the simplified rational function, in other words, cancel your common factors, those would be your vertical asymptotes. Okay, so we set anything in the denominator equal to 0 that is not also represented in the numerator. Okay, so holes in the function are found by determining any zeros of those common factors. So anything that is in common is going to generate a hole in the graph of a rational function. All right, so let's take a look. We've already kind of done this. We do know that 3x squared divided by x minus 5 times x plus 4, we said that the domain, we can look at this and we can look at this, and we can set both of them equal to 0. Okay, and one thing that you want to be sure of is that this is not represented on the top here as well. Okay, so if you have common factors on the top and the bottom that cancel each other out, those would give us holes. These are not found in the numerator, so we can just solve this and we can say our vertical asymptotes would be x equals 5 and x equals negative 4, right? Over here, remember that when we factored this, it ended up being x plus 8 over the product of x plus 8 times x minus 8. All right then, well, first find those common factors. Here are our common factors, right? If I take that and set it equal to 0, that will generate the x value where we see a hole. So at x equals negative 8, there's a hole in that function. But now if I come over here and see what's left on the denominator that is not canceled out, this will give us a vertical asymptote. So x minus 8 is equal to 0, x equals 8. There's a vertical asymptote at x equals 8, but there's a hole at x equals negative 8. The last example over here, remember, what did we exclude from that set of all real numbers here? Nothing, right? Remember, we ended up with some imaginary things, which is not in the set of all real numbers anyway. So if your domain is all real numbers, then there are no holes or vertical asymptotes. Now, keep in mind I'm saying vertical asymptotes a lot because they're not the only kind of asymptotes there are. You can also have horizontal asymptotes or slant asymptotes. So this whole thing that we're talking about refers to how to find vertical asymptotes. Totally different ballgame to find your horizontal asymptotes and your slant asymptotes. That's a topic for another time. We'll see you then. Bye.